The laws of exponents, number and quantity. The number system's Common Core standard says for us to extend the properties of exponents to rational exponents. This is for Ms. Oates and Ms. Wilson's classes. The laws of exponents, part 1. An exponent, you'll also hear it called the index or power. So an exponent, it tells me how many times to multiply the base or the variable. For example, 2 to the third power. 3 is the power, or the index, or the exponent. It tells me to multiply 2 times 2 times 2, which will give me 8. The base, the number or the variable that's taken to a power or exponent. So 2 to the third power, my base is going to be 2. X to the fourth power, my base is going to be x. Please add these words to your words worth knowing, exponent and base. I'll give you a second to copy it down. If you need to, press pause down so you can write the definition and the example. So let's try a few. So if I was to simplify 7 squared, that's 7 times 7. And 7 times 7 is 49. 2 to the fourth power tells me 2 times 2 times 2 times 2. And 2 to the fourth power is 16. How about this one? Negative 6 squared. That tells me negative 6 times negative 6. Remember, if I'm multiplying integers and my signs are the same, my answer should be positive. So negative 6 squared is positive 36. Negative 3 to the third power tells me to take negative 3 times negative 3 times negative 3. And remember when we did the rules of integers, if the number of signs is odd, my answer is going to be negative. So negative 3 times negative 3 times negative 3, I have 3 negative signs. My answer will be negative 27. How about this one? Negative 1 to the fourth power. Well, that's negative 1 times negative 1 times negative 1 times negative 1. Remember from the laws of integers, if the number of signs is even, my answer should be positive. So negative 1 to the fourth power is 1. 2 to the fifth power. 2 times 2 times 2 times 2 times 2. 2 to the fifth power is 32. Now, let's look at some more laws of exponents. A to the 0 power. Any base to the 0 power is going to equal 1. So 5 to the 0 power is going to equal 1. Negative 3 to the 0 power is going to equal 1. Any base to the first power is equal to that base. And remember, if a base has no exponent, there's an imaginary 1 there. It's just that base. So 5 to the first power is 5. Negative 3 to the first power, negative 3. Let's try some. 6 to the 0 power. Any number to the 0 power is what? 1. 2 to the first power. Any number to the first power is that base. So 2 to the first power should be 2. Let's try these. Negative 5 to the first power. Negative 5. Negative 8 to the 0 power is 1. Any number to the 0 power is 1. Negative 9 to the 0 power, 1. Negative 1 to the first power, negative 1. Remember, any base to the first power is itself. Now, let's talk about multiplying exponents with the same base. So if I'm multiplying the same base, I add my exponents. So a to the x power times a to the y power is equal to a x to the x plus y. So for example, in numbers, 2 to the third power times 2 to the second power would be 2 to the fifth power. I'm just going to add my exponents. And then I just solve. Let's look at this one. Remember, I'm going to multiply my numbers and then add my exponents. So I'm going to put all the same bases together. So what's the same? Just like combining the like terms. -5 times -6, those are the same. They're numbers. A to the fourth and A to the second, those are the same. The base is A. B to the third and B to the first. Remember, if I don't see anything, it's an imaginary one. Those are the same. Multiply the numbers in front. So I have 5 times -6. That should give me -30. And then, of course, I'm going to add my exponents. A to the fourth times A to the second should give me A to the sixth. And then B to the third times B to the first should give me B to the fourth. Remember, put the similar bases together, multiply the numbers in front, add the bases that are the same. Try this one on your own. Remember, if there's no number in front of the variable, that's an imaginary one. Did you get 3 into the 8th? Try this one. Did you get 14, x to the fourth, y to the sixth? How about this one? Now, let's talk about raising a power to a power. So I have a base and an exponent, and then it has parentheses, and I'm raising it to another exponent. When taking an exponent to a power, you just multiply them. So if these were numbers, and I had 2 to the second times raised to the third power, I'm just going to multiply the exponents, and I should get 2 to the sixth power. That meant 2 times 2, 3 times. See? Simple. Try this one. Rewrite each base with the power outside of the parentheses. So I'm going to take -4 and raise it to the second power. I'm going to take x to the fifth and raise it to the second power. I'm going to take y to the second and raise it to the second power. Take the number of the base to the power, and then I'm just going to multiply them. So I have -4 times -4, which would give me +16. Then remember, I'm just going to multiply the exponents. So I should have x to the 10th and y to the second. Simple, I know. Try this one. So I'm going to take -3 to the third and to the fifth raised to the third. -3 to the third, we're going to look at those number of negative signs. So I know I should have -27. And I'm going to multiply 5 times 3 into the 15th. Try this one. 9 raised to the second, a to the third raised to the second, b to the fourth raised to the second. 9 squared should be 81. A to the third raised to the second, I should get a to the sixth. And b to the fourth raised to the second, I should get b to the eighth. Try this one. Did you get that answer? If not, look and see where you got your mistakes at. One more. Well, maybe more than one more. Remember, if I'm raising anything to the 0 power, what do?